Today we're going to look at the vertex form of a quadratic relation. So far we have looked at two other forms. We have looked at standard form, which looks like y equals a, x squared plus bx plus c. And that is where the c value represents the y-intercept. So it would be 0 and c. We've also looked at factored form. So that's y equals a, x minus x1, x minus x2, where x1 and x2 represent the zeros or x-intercepts. And the final form we're going to look at is vertex form. And vertex form looks like this: y equals a, x minus h squared plus k. And there's two parameters here, where h and k represent something we're going to look at today. So first let's look at how to graph equations in vertex form. So our first example, I've given you two quadratics in vertex form. Remember that it's y equals a, x minus h squared plus k. So we can see for this one, our a is -2, our h is +3. Remember it says minus h, so -3. And our k is 5. So let's see what happens when we sub some values into this vertex form, and let's graph this relationship. So we want to figure out the y values. So let's start off with x equals 1. So I get y equals -2, 1 minus 3 squared plus 5. Using order of operations, that's -2 times -2 squared plus 5, which gives me -8 plus 5, which equals -3. So take a moment now and see if you can determine the rest of the y values. So hopefully you've tried that, and you see we're going to get 3, we're going to get 5, 3, and -3. And if we graph that, so there's our 1, -3, our 2 and 3, our 3 and 5, our 4 and 3, and our 5 and -3. We get a parabola which opens downwards. But let's take a look at the vertex of this parabola. So here is our vertex. And you notice our vertex has the coordinates 3 and 5. And if you look closely at our vertex and our h and k value, you should notice something. It appears that our h and k value is our vertex. Well, let's try it again and see if that's true. So let's look at one more equation in vertex form. So y equals x plus 2 squared plus 3. If we take a look at this again, we see our a value is 1. We see our h value is -2, because remember it's x minus h, so x minus -2 gives me x plus 2. And finally, we see our k value is equal to 3. So based upon what we saw before, our vertex should be at -2 and 3. So let's sub this into our table of values. So this time I'm starting with x equals -4. So I have y equals -4 plus 2 squared plus 3, which is -2 squared plus 3, which is 4 plus 3, which gives us 7. So that is our first value. And then if you try the rest, you should get the following y values. So let's plot this. So we have -4 and 7, -3 and 4, -2 and 3, -1 and 4, 0 and 7. And if we graph this parabola, we see our vertex here is at -2 and 3. And indeed, that matches our h and k value. So once again, we see our vertex is whatever our h and k value will be. So this is called vertex form because in the form you have the coordinates of your vertex. So let's summarize. So vertex form is y equals a x minus h squared plus k, where h represents the axis of symmetry and k represents our optimal value. And both together give us our vertex. So the vertex is h and k. For example 2, we're going to take our equation in standard form and rewrite it in vertex form. And in order to do that, we first need to find the vertex. And to find the vertex, we are going to use symmetry, because this is the more efficient way to find a vertex. So recall, for symmetry, we're going to let y equal the c value, which in this case is -1. We're going to sub -1 into our equation. We are going to get 0 on the left side by adding 1 to both sides. So this is our equivalent expression, which will help us find the roots by solving for the zeros of this expression. So to do so, we need to take a common factor. So we take out a -7x, and that leaves us with an x minus 6. We solve for the roots by setting each of these factors equal to 0. The first one we're going to divide by -7 on both sides. So that gives us a 0 at 0, or a root at 0. The second one, we're going to add 6 to both sides. So that gives us a root at +6. So this gives us the 2 points, 0, -1, and 6 and -1. Because remember, y was set as -1. So next we need the axis of symmetry, which we call is x1 plus x2 divided by 2. So that's 0 plus 6 over 2, which gives us an axis of symmetry of 3. And then we need our optimal value, so we're going to sub this axis of symmetry into our equation. So that's -7, 3 squared, plus 42 times 3 minus 1, which gives us a y value of 62. So we have a vertex that has the components 3 and 62. So remember, vertex form looks like this: y equals a x minus h squared plus k. So our vertex here, there's our h and there's our k. But we also have the a value. If you look at the start here, the -7 is our a value. And we know that a equals -7 from standard form. So now if we sub these all in, we get y equals -7 x minus 3 squared plus 62. And this is our equation in vertex form. Again, the h and k is our vertex, and the a value was already stated in standard form. Let's do this one more time. So going through the same steps, we need to find the vertex, so let's use symmetry. So we're going to let y equal 5. So we end up with 5 equals x squared plus 20x plus 5. We subtract 5 from both sides, and we get x squared plus 20x. We common factor. That gives me x and x plus 20. We solve for the roots of this equation. So x1 is going to be 0, and x2 is going to be negative 20. Next we find the axis of symmetry. So that's 0 plus negative 20 divided by 2, which gives us an axis symmetry of negative 10. Now we look for the optimal value. So that's y equals, sub in our axis of symmetry, negative 10 squared plus 20 times negative 10 plus 5, which equals 100 minus 200 plus 5, which gives us negative 95. We now know our vertex is negative 10 and negative 95. So now we can rewrite this in vertex form. So y equals a, x minus h squared plus k. Again, there's our h, there's our k, and up here would be our a value, which is going to be 1. So again, and we know that a equals 1. So in our vertex form, we have y equals 1, x minus negative 10 squared minus 95, which we can just simply write as x plus 10 squared minus 95. So that is our vertex form for this equation. So in this example, we're going to write the equation of each parabola in vertex form. But we need to determine the a value for these ones. So using vertex form, we know that y equals a, x minus h squared plus k. From the graph, we have a few key points. Let's start with this point. We have our vertex. And our vertex is, remember, it's our h and k, and it equals negative 3 and 1. So if we sub that in, we get y equals a, x minus negative 3, so that's x plus 3 squared plus 1. Now we need another point to solve for a. So if we look for a point on the graph, so here's one. That's going to be our next point. So that is negative 2 and 3. We can now solve for the a value. So 3 equals a, negative 2 plus 3 squared plus 1. And all we need to do now is solve for a. So we get 3 equals a. That is going to be 1 squared plus 1. So 3 equals 1a plus 1. Move the 1 to the other side. So we get 2 equals a, or subtract 1 from both sides. We now have our a value. We see it's positive, which is good because the parabola opens up. And therefore, the equation of this quadratic is y equals 2, x plus 3 squared plus 1. So there is the equation for this parabola in vertex form. So let's do that one more time. So again, starting with vertex form, y equals a, x minus h squared plus k. First thing we need is a vertex. So the vertex we can see there is 4 and 5. So that gives us y equals a, x minus 4 squared plus 5. Now we need a point. So let's find a point. Look at that. We'll take a 0 here. So we have the point 9 and 0. So 0 goes in for y, 9 goes in for x. So we get 0 equals, so 9 minus 4 is 5, and we square that. So we get 25a plus 5. These are unlike terms, so I'm going to subtract 5 from both sides. to solve for a. So I get negative 5 equals 25a. And then I'm going to need to divide both sides by 25. And if I do so and simplify this fraction, I get a equals negative 1 over 5. So therefore, the equation of our parabola is y equals, there's the a value, there's x minus 4 squared plus 5. So there's the equation for this graph in vertex form.